Welcome to this explainer. Have you ever been to a live concert or a festival and just found yourself staring in total awe as those vibrant, piercing beams of light slice right through the darkness? I mean, it's an incredibly immersive spectacle that honestly feels almost like magic. But when you stop to really think about it, we are literally shooting highly concentrated, high-powered beams of radiation directly over and sometimes straight into a crowd of thousands of people. So how is that actually safe? Well, today, we're going to demystify the unseen science behind the lights.
Our main goal in this explainer is to uncover the invisible science that's working behind the scenes to keep you safe. We're going to explore the microscopic physics of light along with the rigid architectural rules that protect our eyes, and we'll see how they manage to do all of this without killing the vibe of the event. It really is this fascinating intersection of biology, physics, and some very strict regulations.
Okay, let's dive right into our agenda. First up, the science of eye safety. Second, decoding show laser classes. Third, mapping the safe zones. And finally, the laser safety officer.
Section 1. The science of eye safety. Zooming in on the biology and physics of light.
So, the inherent danger of a laser is that it concentrates a massive amount of energy into a super tiny beam. If that raw, unmitigated power hits the fragile tissues of the human retina, the damage can be instantaneous and unfortunately permanent. To prevent that from ever happening, safety engineers rely on a very specific baseline, 7 millimeters. That is the internationally recognized maximum diameter of a dark-adapted human pupil. You know, when you're in a dark club or a massive arena, your pupils naturally dilate to let in as much light as possible. Safety experts use this exact 7 millimeter opening as the universal standard for absolutely all of their risk calculations. It is the core target we absolutely must protect.
And to protect that 7 millimeter target, we rely on a critical metric called the MPE, or maximum permissible exposure. Now, if you're looking at German safety regulations, you're going to see this referred to as the MZB. But essentially, this is the absolute maximum level of laser radiation that the human eye or skin can safely receive before it sustains damage. And here's the kicker. There is no single safe power level for a laser. Safety is always this complex calculation based on exactly how much power enters that 7 millimeter space and exactly how long it stays there. Which brings us perfectly to a concept called audience scanning. That's when lasers sweep directly over a crowd to create those awesome tunnels or sheets of light. Think of it like a strobe light. Every single time a laser draws a circle in the air and that beam rapidly crosses your eye, it hits you as a quick flash or a pulse. Your eye absorbs that pulse of light, and crucially, it needs a little bit of time to recover before the beam comes spinning back around. If those pulses come too quickly, the eye simply cannot handle the accumulated energy.
Because of this compounding effect, a safe audience scanning show actually has to pass a really rigid 3-step test. Step 1 evaluates the single pulse MPE, so that's the safety of just one single flash across the eye. Step 2 looks at the multiple pulse MPE, measuring if the eye actually has enough recovery time between those rapid repeating flashes. And finally, Step 3 calculates the average MPE, tracking the total power received over a longer duration, like 10 seconds. A show must strictly pass all 3 of these limits simultaneously. If it fails even one, no way it is considered entirely unsafe.
Moving on to Section 2, Decoding Show Laser Classes, Understanding Power Output and the Inverse Square Law.
Now that we've got a handle on the biological limits, let's take a look at the actual hardware. Under comprehensive safety standards, laser equipment is strictly categorized by its inherent danger level. So, a basic Class 2 laser, like your standard office presentation pointer, operates at under 1 milliwatt. For that, your natural blink reflex will protect you. But show lasers, those are Class 3B and Class 4 monsters. A Class 4 laser outputs over 500 milliwatts. That is immense power that will instantly damage your eye or skin way before you can even think about blinking. These high-powered machines require intense, carefully calculated safety measures.
So, how do you actually make a Class 4 laser safe enough to shine anywhere near an audience? Well, you might naturally think the answer is just to turn down the laser's power, but actually, enlarging the beam's diameter is vastly more effective. This all comes down to the inverse square law in physics. Check this out. If you double the size of the laser beam, you don't just have the power, the irradiance drops to 1/4. Tripling the size makes it 9 times lower. Sure, the beam might look slightly fuzzier to the audience, but a vastly smaller fraction of that light can actually fit into a 7 millimeter pupil at any given moment. It's just a really elegant mathematical trick that maximizes the visual impact while drastically slashing the danger.
Section 3.
Mapping the safe zones. Zooming out to the spatial geometry of a venue.
Now, out in the real world, the absolute most practical, foolproof way to protect a massive crowd is through sheer physical space and careful geometry. According to regulations, there is a mandatory 2.7-meter or roughly 9-foot vertical clearance zone. Any laser effects that exceed those safe MPE limits we just talked about must remain absolutely locked above this height. It essentially creates this invisible safety ceiling over the room. Below this 2.7-meter line is your safe audience area, and above it is the hazardous, strictly controlled laser zone. But you know, height alone isn't quite enough, especially when you factor in things like balconies or raised seating. Because of that, there must also always be a mandatory 1-meter horizontal separation rule. This means there needs to be at least 1 meter of lateral buffer space between any audience member and that hazardous laser zone. It physically prevents anyone from reaching out over a railing or a barrier and accidentally putting their hand, or worse their eyes, into an unsafe beam.
So when you put all this geometry together, the room is strictly divided into 3 distinct zones. First, you have the show laser barrage, which is the active show area where those MZB limits can legally be exceeded. Second is the two-shower barrage, the audience area, and this space must be strictly kept below safety limits at all times. And finally, the bedeem barrage, the operator zone where the technicians sit, which obviously also must remain absolutely safe. Through this rigid spatial geometry, all that dangerous light is kept strictly corralled away from the public.
Section 4. The Laser Safety Officer. The human element enforcing the regulations.
Okay, so you can have all the inverse square math and 9-foot safety ceilings in the world, but rules don't just enforce themselves, right? A proper laser show requires a dedicated, highly trained human expert on site. In Germany, the person who weaves this whole thing together is the Laserschutzbeauftragter, or the laser safety officer. Before the first beam ever fires, they're the ones drafting comprehensive hazard assessments and physically demarcating those safe zones. And during the event, they are continuously monitoring the live show. If there's an equipment failure, a change in safe operating conditions, or even if the crowd just gets too unruly, the LSO is the ultimate authority. They have the power and the absolute duty to hit the emergency stop button and instantly kill the lasers.
And to actually do this job, LSOs have to master an incredibly dense alphabet soup of regulations. We're talking domestic occupational safety laws like the OSTV-RV, industry-specific rules like the DGUV guidelines, the German show laser standard DIN 56912, plus international frameworks like the IEC 6825-1. It is a massive amount of homework, but it's all dedicated to ensuring that every single pulse of light is both legally compliant and physically harmless to you.
All of this leaves us with a pretty provocative question to end on. Is the true artistry of a laser show really found in the blinding light? Or is it actually found in this invisible, meticulously crafted web of physics, geometry, and safety regulations that allows us to stand right in the middle of it and enjoy the whole thing without an ounce of fear? Honestly, the next time you're at a show, I hope you look up at that invisible 2.7-meter ceiling and appreciate the unseen science protecting you. Thank you so much for joining me on this explainer, and keep learning.